Have you ever really stopped to think about how we can pinpoint an exact location? Whether it's a tiny dot on a page or a specific house in a huge city, it all boils down to this brilliant and, believe it or not, super simple system. Today, we're going to pull back the curtain on coordinate geometry. It's like the hidden grid that secretly maps our entire world. Let's dive right in. Lewis Carroll really hit on something important here. To make any sense of space, we have to have rules we all agree on, or as he called them, conventional signs. Without a system, we're just lost. And that simple idea is really the foundation for everything we're about to explore. So, here's how we'll break it down. We're going to start with the basic problem, just trying to find a location. Then we'll meet the thinker who came up with a brilliant solution, and we'll build his system from the ground up. After that, we'll learn how to speak its language and see how it organizes the entire world into 4 neat little sections. All right, first up, the location problem. At its heart, this is all about one simple thing, the need for a precise, unmistakable address for everything. No, seriously, think about it. If I asked you to find something, how would you give me instructions that leave absolutely zero room for confusion? Just saying something is over there doesn't really work, does it? I mean, imagine you're looking for a friend's house and I just say, oh yeah, they live on street 2. You'd be wandering around for ages. But if I say, they live at house 5 on street 2, bam, you know exactly where to go. You need those 2 key pieces of information. And it's the exact same idea for, say, this dot on a page. Telling you it's near the left edge is pretty useless. But if I tell you it's 5 centimeters from the left edge and 9 centimeters from the bottom edge, now that is an exact, unique address. No guesswork needed. So this brings us to what I like to call the 2 information rule. It's the key takeaway here. To find any point on a flat surface, what we call a plane, you just need 2 measurements from 2 fixed lines that are perpendicular to each other. One tells you how far to go sideways, the other tells you how far to go up or down. Now, this simple but incredibly powerful idea wasn't just some random thought. It was actually formalized into a whole system by one particular thinker. So let's find out who the brain behind this whole operation was. His name was René Descartes. He was a French philosopher and mathematician back in the 17th century, and he's the guy who took this basic need for 2 pieces of info and turned it into the elegant, powerful system we literally use every single day. And get this, the story goes that he loved to just lie in bed and think. And it was during one of these lazy mornings that he supposedly had his eureka moment and cracked the problem. But what's really cool is that his method wasn't totally new. It was actually a brilliant spin on the much older idea of latitude and longitude that we use to map the Earth. So in his honor, we call this whole thing the Cartesian system. And now let's actually build his map, the Cartesian Plane, right from the very beginning. Okay, it all starts with something super familiar, a number line. We just lay it down flat, horizontally. We put 0 in the middle, positive numbers stretch out to the right, and negative numbers go to the left. We call this the x-axis. All right, step 2. We take another number line, but this time we stand it straight up, vertically. Positive numbers go up, and negative numbers go down. And this, you guessed it, is the y-axis. Now, this next spot is probably the most important point on the entire map. We make these 2 lines cross right at their 0 points. This special intersection is called the origin. Think of it as the grand central station. It's the starting point for every single measurement. Its address is simply 0, 0. So let's just lock in the lingo real quick. The 2 lines together, we call those the coordinate axes. The x-axis is your horizontal line, the y-axis is your vertical one. Moving right or up is positive, moving left or down is negative. Simple as that. Okay, so we've built our map. Now we need to learn how to actually read it and write on it. It's time to learn the language of coordinates. So every single location or point has a 2-part name. The first part is the x-coordinate, and it tells you how far to move left or right from the vertical y-axis. The fancy name for this is the abscissa. The second part, the y-coordinate, tells you how far to move up or down from the horizontal x-axis, and that one is called the ordinate. And right here, this is probably the single most important rule in the entire system. It's the convention the whole world agrees on. The x-coordinate always comes first, the y-coordinate always comes second. We write them in parentheses, like this, x, comma, y. So let's put that rule to the test. Is the point 3, 4 the same location as the point 4, 3? What do you think? No way, absolutely not. The point 3, 4 means you go right 3 and up 4. The point 4, 3 means you go right 4 and up 3. They're two totally different spots. In this system, order is everything. And now for the final piece of the puzzle. Let's see how these two simple axes create this beautifully organized map. It's all about the 4 quadrants. So check this out. The x and y axes slice the entire flat surface into 4 distinct sections. We call these quadrants. And here's the slightly quirky part you just have to remember. We number them I, II, and IV, starting in the top right and moving counterclockwise. This table is basically your cheat sheet, and it shows the pattern perfectly. In quadrant 1, you're going right and up, so both x and y are positive. Jump over to quadrant 2, you're going left and up, so x is negative, but y is positive. Down in quadrant 3, it's left and down, so they're both negative. And finally, in quadrant IV, you're going right and down, so x is positive while y is negative. But wait, what about points that are in a quadrant, but are sitting right on one of the lines? Great question. Any point that's on the horizontal x-axis hasn't moved up or down at all, right? So its y-coordinate is just 0. Its address is x, 0. And by the same logic, any point in the vertical y-axis is at 0, y. And our good old friend, the origin, is right in the middle at 0, 0. So there you have it. A beautifully simple system of two perpendicular lines that gives us a unique, exact address for any point on a flat surface. Now that you know the rules, the real question I have for you is this. Where do you see this system hiding in plain sight? Think about the screen you're watching this on, or a spreadsheet, or even the map in your favorite video game. Once you see it, you'll realize it's absolutely everywhere.